I'm Scott Mitchell. I'm the director of the Orange Coast College Planetarium. We're the newest building on the OCC campus. We're in Costa Mesa. We opened on March 22nd, was our dedication ceremony, ribbon cutting, and all of the pomp and circumstance that a $25 million planetarium deserves. Yeah, it's a really, really incredible building, and I'm just going to kind of talk about some of the things that we have available to the people that come and visit, some of the shows and public events that we're doing, and plans for the future. So, of course, this is the exterior of our building on campus. You can see the tall part in the back is the tower for our focal pendulum. We've got a huge lobby that's just glass all the way around, big windows to let in lots of natural light. And then, of course, in the center is our 50-foot diameter state-of-the-art planetarium dome. So on the right, you can see the focal pendulum, which is a tool that demonstrates the rotation of the Earth. French physicist Leon Foucault in Paris, France in the 1800s developed this apparatus as a way to demonstrate that the Earth is rotating. The pendulum itself swings back and forth in a fixed plane, always in the same direction, and the Earth rotates underneath it, which causes it to appear to us, as we stand on the Earth, to precess around in a circle. Our pendulum here in Costa Mesa, since we're at about 33.7 degrees north latitude, goes around in full precession, 360 degrees approximately every 43 hours. Since it's knocking over pins on either side of its swing, it takes about 22 hours to knock them all down. The precession period depends very much on the latitude at the North Pole. It would take exactly 24 hours to go all the way around. At the equator, it wouldn't go around at all. And at the South Pole, it's 24 hours again, but counterclockwise rather than clockwise. It's a really, really popular exhibit. Kind of a mystery to me why it was so popular. To me, it just was kind of boring, but everybody crowds around it and loves to stare at it, and they cheer when it knocks the pins over. So, of course, they've got one at the Griffith Observatory. Ours is much newer and shinier, but I don't want to brag that much. On the other picture on the left-hand side is from an event that we did back in January, kind of a soft opening event for the total lunar eclipse. We had several telescopes out. We invited the public and put on just a short little show talking about the moon, what was actually happening with the eclipse, why eclipses happen, and then using the planetarium, we were able to actually watch the eclipse from the surface of the moon near the Apollo 15 lander. So that was, I thought, a fun touch. So this is on the right is another image of the lobby. You can see the pendulum kind of in the back there. The kind of blown out circle in the foreground is our NOAA Science on a Sphere exhibit. NOAA is the National Oceanic and Atmospheric Administration, and they provided this exhibit. It's essentially a 6-foot carbon fiber sphere that hangs from the ceiling, and we can project basically whatever we want onto it. Normally we're showing the Earth with real-time clouds. We can show real-time wind speed, ocean currents, flight patterns, droughts, carbon emissions, all kinds of really, really cool data sets compiled by NOAA. We can show the moon, the other planets of the solar system. It's a really good tool for teaching about the environment, climate change, plate tectonics. I have several faculty members from all over campus just itching to get in and bring their classes to use it. I've got history professors that have data sets that we can project onto the sphere that show the spread of the Black Plague. I've got a geology professor that was almost wetting himself to show his students the data set that shows the magnetic declination of the Earth and how the magnetic poles change over time. So lots and lots of really, really cool things that we can do on the Science on a Sphere. Not pictured down the hallway towards the entrance to the theater, we have 4 Science on a Sphere Explorer stations, which run basically the same software, but they're on a flat touchscreen We have 4 touchscreen interfaces that do Science on a Sphere Explorer, which is essentially the same software, but it allows people to interact with it on their own. So we can do a full lecture with 50 people around the actual globe, talk about whatever the class is interested in, and then we can break them up into groups, send them over towards the Explorer stations, and they can explore the exact same data sets on their own. They can zoom in, look at things up close. We can put together lessons for them to find and answer questions about all kinds of things for the ocean, volcanic and geologic activity, atmosphere, even the planets of our solar system, satellites. There is really a ton of stuff. It's a very, very versatile piece of software. Over 200 different data sets that we can show on the Science on a Sphere and the Science on a Sphere Explorer. The other image on the left is of the interior of the planetarium. The pictures really, of course, don't do it justice. It's very difficult to photograph in that room because it has to be so dark. But we have a 50-foot diameter aluminum dome that is lit by 6 very powerful Sony laser phosphor projectors, which fill the entire dome with 8K resolution video and imagery. And it allows us to do a lot of really, really cool things for visitors of all ages. We had our very first field trip just Friday of last week. A group of 8th graders came and took a tour through the solar system. Our second one is going to be on Monday. They're going to learn about the Earth, the Moon, and the Sun. And then on Tuesday, we've got another class coming that'll be looking at the jobs of astronauts and astronomers and how we use telescopes and research to learn things about our universe. So the software that we run inside the planetarium is called Digistar 6, and it allows us to basically create a scientifically accurate 3D model of the entire visible universe. We can pull actual real data sets from the Sloan Digital Sky Survey and just fill the dome with other galaxies and fly around through them, explore galaxy clusters, talk about dark matter, the expansion of the universe. We can fly to all kinds of different places in our own galaxy. There are built-in databases full of exoplanets from the Kepler mission. Each one of the exoplanets has been painstakingly illustrated by artists, and so we can fly to these exoplanets and actually see what their surfaces might look like. And of course, in our own solar system, where we have much more information, the Earth, we have 3D terrain models, so you can fly right through the Grand Canyon or look up at Mount Everest. The same goes for Mars and the Moon. We can fly right up close to Olympus Mons or through the Mariner Valley. We can land on the Moon next to Apollo capsules and all kinds of really, really cool things. Our programs that we do for the public, which are on weekends, Friday nights at 7 o'clock, and then Saturday and Sunday at 11, 12:30, and 2. Usually we'll introduce the program with a live presentation done by me or one of my student staff, and then a approximately 30-minute full dome multimedia presentation. And then we finish up every show with a tour of the night sky that you would be able to see from a much, much darker place than Costa Mesa that night. It's no fun with the light pollution on, so usually I ignore the light pollution so that we can see more than 5 stars in Orion. But it allows us to kind of let the audience take something home after every show so that they can go out and, even if they can only see Mars or Sirius, then it's something that they might not have been able to do before. So the next couple of slides I've got are just trailers for some of the shows that we're doing. This is Explore, and it was kind of our premiere show that we showed on the night of the grand opening on March 22nd.
Since the dawn of humanity, we have gazed up at the stars, dreaming one day perhaps to reach them. And if we are to outlive our planet, we will need to make this dream a reality. With modern technology, we can travel beyond Earth's atmosphere. But this isn't all new science. We are benefiting from the discoveries of generations of scientists reaching back into history.
Launch control, SSE. Station disconnect enable sequence is complete. SSE, we copy. You are good for driving gauge auto start sequence.
Have you ever wondered how a spacecraft can navigate accurately to a space station traveling at 20 times the speed of sound? Knowledge and skills gained from the missions to the International Space Station have paved the way for the next historic step for human space travel: to land on another planet, Mars.
So that's Explore. That's kind of our premiere show. I don't know if the sound is loud enough for everybody to hear, but it focuses on how our perceptions of the universe have changed drastically over the course of history, starting with seeing just the lights in the sky, not really understanding what they were. Ancient people believing that the stars were affixed to crystal spheres that rotated around the Earth, and that the sun and the moon, well, the moon does, but that the sun and all of the other planets orbited around the Earth. How Copernicus, Galileo, and Kepler changed that model to put the sun in the center of the solar system, and then how Kepler's laws allow us to calculate the orbital parameters that we need to be able to send missions to the moon, send people even further out to Mars someday. So it's a really, really just visually impressive program. Of course, a slide isn't going to do it justice. This is our kids show, which is at 11 and 2 on Saturdays and Sundays. It's called Earth, Moon, and Sun, and it's just a really fun way to engage kids to learn about the phases of the moon, seasons, eclipses, just the motion in the sky that we all kind of take for granted, that the sun rises in the east and sets in the west, that the stars change depending on what season we're in as we orbit the sun. And it's all presented through the lens of Native American folklore. The coyote is supposed to be a kind of trickster character in that folklore, and so he messes a lot of things up, addresses a lot of misconceptions, like that the phases of the moon are caused by the moon moving in and out of the Earth's shadow, things like that. People that don't really have a lot of background in astronomy might go in thinking, and it addresses those in a really just kind of fun and engaging way. It's one of our more hands-on programs. At the beginning, in the live intro part, we want to compare the size of the sun and the moon, so I invite the entire audience to help me lasso the sun and drag it 93 million miles closer to us before deciding, as the dome turns bright red, that it was a terrible idea and we're all going to die. So I like to have fun with stuff like that.
What's the age of the variable that that will talk to you?
Oh yeah, so the Explore show, I think we've got 10 and up is the recommended ages. This one is ages 6 to 12, but even then, you know, I really like watching it. So it's just a really fun program, and I think probably anybody that comes in will take something away from it, even if you think you know quite a bit about astronomy. This one is, we'll show this one. We just got this program. I got it running on Tuesday. It's called Capcom Go, and it's the Apollo story.
I believe that this nation should commit itself to achieving the goal, before this decade is out, of landing a man on the moon and returning him safely to the Earth. No single space project in this period will be more impressive to mankind or more important for the long-range exploration of space.
In 1961, John F. Kennedy set the goal to send a human to the moon. Discover the story of how we did it. Capcom Go, the Apollo story.
Obviously, the 50th anniversary of the Apollo 11 mission is this July. So we got this one. This is a brand new show. It was world premiere was just a couple of weeks ago. So we got it on the ground floor. It's a really just visually very impressive show. It talks about all of the lead up through the space race to the actual landing, and then through the rest of the Apollo missions, and our plans to hopefully go back to the moon in the not too distant future. So our dedication ceremony was on March 22nd. We had local representatives, lots and lots of VIPs coming to help dedicate the building. We really want to be able to give back to three kind of main groups in our community. Because as a community college, we rely very much on the people around us, and the college receives a lot of great benefits from our community, and so the planetarium is kind of our way to give back. We of course will be addressing the general public with our public programs on weekends, and then special events for eclipses and transits, things like that. The anniversary of Apollo, and so that's just free for anybody to come in and purchase a ticket and take in a star show. We have our field trip programs for K through 12 students from as far out as I've got a school from Long Beach that wants to come all the way down here to see us. So very ambitious field trip program. We're working with the Orange County Department of Education to develop standards-based programming so that a teacher can come in and basically just check off a whole lot of boxes, saying that the planetarium has addressed all of these different standards that they are required to teach with the California state standards. And then of course the third group that we want to address is just the campus community. The planetarium is a very useful tool for lots and lots of different departments, not just the astronomy department, although of course they'll probably use it the most, given that we don't have a really great dark sky in Costa Mesa. The planetarium is a really great opportunity for the students to be able to learn how to find things in the sky, learn how to measure things in the sky, and a great way to just visualize things that you can't really do on a flat screen. But of course, we're definitely not limited to astronomy. There are programs that I plan to get for the dome that talk about everything from marine ecology, botany, paleontology, weather, all kinds of things that we can do in the dome. It's definitely not limited to astronomy anymore. And on top of that, we can create our own content very easily with a $200 GoPro camera. We can create full dome video. One of the marine science professors takes a field trip to Baja California every year to go gray whale watching, and I'm gonna give them a 360 GoPro that they can just stick in the water next to the whales, and then we can put that on the dome and feel basically like you're immersed in this environment, swimming with the whales. And then of course we can create a lot of custom astronomy content. Our campus marketing department and videographer have been doing really great jobs kind of experimenting with this new medium of 360-degree video. I've been talking to people from the art department. I've got a group of a dance class that's going to come and perform in the lobby in a couple of weeks. So it really is a huge multidisciplinary facility, and I don't want to keep anybody out, which is getting to be a scheduling problem, but that's my problem. So I think we can play this one. This one's just 30 seconds. This is just a commercial that we shot for the building.
Imagine a place where children explore the mysteries of the universe, where college students navigate new worlds of opportunities in science, technology, engineering, art, and math, where families and friends encounter galaxies millions of light years away. Imagine a world-class space to discover infinite possibilities. The Orange Coast College Planetarium. Visit our website for showtimes and ticket information.
Yeah, so that actually reminded me of a couple of different things that I didn't mention. With this building it being $25 million, we ought to have some really cool toys in there. Even the windows are special. Since our lobby is essentially all windows, it would ordinarily be very difficult to project onto the science on a sphere and not have it appear really washed out and not look very good. So every single pane of glass in the entire building is electrochromic, which means that with the push of a button, I can darken all of the windows in the building, and tint them to make a nice dark environment so that we can see the projection even in the middle of the day. The floors even have 2 feet of space underneath them. You can pull up the tiles so we can run power and data underneath the floors, so there's no tripping hazards, extension cords all over the floor, and we can run it straight back up to illuminate display cases for exhibits. If we want to run, put big monitors and TVs in the lobby, we can run all of the data for those underneath the floor. There's plans, hopefully by next fall, to install a telescope farm just out on the lawn in front of the planetarium, where we'll have several, like 10 is the plan right now, just permanent piers fixed to the ground, so that the astronomy students don't have to load tripods around. They just put the OTA on top of the mount, and it's already aligned, and they can just get right to observing. It really cuts down on the amount of equipment they have to carry around. And then we have a big, can't remember the exact size, but a hydrogen alpha solar telescope that will go in its own small observatory dome out there too, so that we can put that on the output from that onto a big monitor. We can show it inside the planetarium dome if we want to, and it'll really make it a very, very powerful tool for the astronomy students and for the planetarium when we have school field trips coming. They can, in addition to being able to see the things on the globe, look at the Foucault pendulum, they can go outside and look at the sun through the solar telescopes. So yeah, lots of really, really cool things that we've so that's kind of what we've got going on right now. We're planning several events for the anniversary of the Apollo landing, and as other things come up, we'll definitely be advertising those too. But yeah, normal shows right now that we're running Friday, Saturday, and Sunday. You can get the tickets right on our website already, orangecoastcollege.edu/OCC Planetarium. Yeah, I've got brochures that are on the table in the back there that you can feel free to grab, and I think that's all I've got. So questions? Yeah, how about we'll start right here. Yeah, so how about?
I was curious as to how the school came up with $25 million for this.
Yeah, so the question is how did the planetarium come up with $25 million to build the facility? $20 million of it came from a tax bond, Measure M, which I think passed back in 2016, supplied all of the community colleges in the state of California with funding. OCC put $20 million of it towards the construction of this facility, and then through private fundraising, we were able to raise another $5 million to round out the corners.
I wondered if you have like memberships where you can have an annual membership to the planetarium.
Yeah, so the question is, do we have annual memberships? At the moment, they're not set up yet, but there's a button on our website that if you click it, it says memberships coming soon. So we're definitely working on it, and that will hopefully be active by the end of May, if I can find the time to work on it. Yeah, Phantom of the Universe is a really cool program. It's produced in part by CERN, the Large Hadron Collider in Switzerland, to talk about the search for dark matter and what this mysterious particle might be, since there's no way to detect it outside of looking at how it affects things through gravity. It's a really, really cool program that's definitely our most scientifically advanced, I'll say. We've got shows that run for elementary school, middle schoolers, high schoolers, but this one is good for, actually, we've got higher level astronomy classes coming in a couple of weeks to see the same show. So it's a really, really cool program, and the best part was that it was distributed entirely free by the European Southern Observatory. So thank you, ESO. Right, so the planetarium at Griffith has a hybrid system with an optomechanical starball, the giant machine in the middle of the room that has fiber optic lights to project very, very gorgeous, very crisp star field with literally infinite contrast between the stars. Unfortunately, with an optomechanical system like that, the night sky is the only thing you can do with it. You can put up gorgeous pinpoint, very bright stars, but you can rotate them, and that's about it. With the digital system, so we don't have a star ball. Ours is powered by 6 big laser phosphor digital projectors around the sides, around the perimeter, that shoot across, and each one does a different segment of the dome. But it allows us to put up a really, really gorgeous night sky, not quite as good as we would have been able to get with an optomechanical system, but still really, really good resolution, very high contrast, and we can push a button and pick up off of the Earth and fly to Mars.
How many people can you fit in the planetarium auditorium?
Excellent question. We have seating for 125 inside the planetarium.
Okay, and what about that Apollo presentation? Is that going to be a show soon, or?
Yes, so these, the 2 shows that we're running right now, Explore and Earth, Moon, Sun, will run through the end of June, and then we'll replace Explore with Capcom Go, which is our Apollo show, and then Earth, Moon, and Sun will be replaced with a program called Magic Treehouse Space Mission. I don't know if anybody has grandkids who absolutely adore the Magic Treehouse book series, but it's a very, very popular book series. Every 3rd grader in the country reads them.
Thank you very much.
Yeah, you're very welcome.